everyone, welcome back. I'm Domingos. I'm also known as DMA and appreciate when I'm called DMA. So today we have this integral. This is from Calculus 2. It was in a university in Peru, America. So we're going to solve this problem. So for this problem, the first approach that we have to consider is the power rules, a to the power n minus m. We know that it's a to the power n times a to the power negative m, or it's the same as writing a to the power n over a to the power m. So we know that. So this approach we can apply here. They say p is non-negative number, means p could be 0 or positive number, we don't know what number, and a is different than b. So they are not the same. Okay, so this expression can be transformed into 1 over a to the power m. So this approach we're going to apply in this problem. So we're going to have now x minus a to the power p over x minus a times, if we factorize negative there, then we're going to have this will be positive, right? So we can apply this approach that we applied here, which is 1 over a to the power m. So in this particular case, we're going to have 1 over x minus b to the power p times x minus b dx. Okay, because they have the same base, we can just simply add the exponent will be p plus 1, which is this p plus 1 that we have there, and this one is because of the negative. Now this expression has exponent p and this has exponent p, so we can keep it. So we can say this is x minus a over x minus b all to the power p. And then times, if we check, this expression has no p, this has no p, we can multiply. So we can say this is 1 over x minus b times x minus a. Okay, dx. Okay, but if we look, we can apply decomposition in this expression. We can separate it. But for us to apply decomposition, since the numerator is 1, we can simply subtract these two expressions to see what we get. Okay, so we can apply decomposition here. But first, what we can also consider is if we subtract x minus b minus x minus a, we get x there will be cancelled out. So it will be minus b plus a. In other words, a minus b. So that means the difference of these two denominator is equal to a minus b. Because it's equal to a minus b, this expression can be reduced into integral x minus a over x minus b all to the power p times this expression that is produced by subtracting my denominator. So will be 1 over a minus b, and then I can split them since the numerator is 1. So it will be 1 x minus a minus 1 x minus b. Okay, dx. Because if you cross multiply, find the common denominator, this x minus b will be here, like here, and x minus a will be here. So you will have the difference, and a minus b, that's the result, will be simplified with this a minus b and then goes back there. Okay, now what do we do? If we check, this expression here is a constant, can go outside. So this can go outside, so it will be 1 over a minus b integral of x minus a over x minus b whole to the power p times 1 minus x minus a minus 1 over x minus b dx. Okay, now if we check, this expression comes from the derivative of ln, natural logarithm, and this expression also comes from the derivative of ln, natural logarithm. So what we can do, then we can say this will be equal to 1 over a minus b, and this will be integral of x minus a over x minus b to the power p times, we know that this one comes from derivating ln, right? So in other words, this expression, this two expression, comes from derivating The first one comes from derivating ln of x minus a. The second one comes from derivating ln of x minus b. Okay, we're gonna have this expression and we're gonna have this expression. Now, if this derivative gives me this one and this derivative gives me this one, we can apply the logarithm rules, which is ln of a minus ln of b. It's dividing the arguments. So this is gonna be equal to 1 over a minus b integral of x minus a over x minus b to the power p. Derivative, if I apply the rule, I'm gonna have ln of x minus a over x minus b. Okay, the derivative of this expression. But we realize we have now our argument, the derivative of ln, but we don't have ln here. We can introduce ln. But to introduce ln in this particular case, what is gonna happen? I'm gonna implement Euler to the power ln of x minus a over x minus b to the power p. Derivative of ln of x minus a over x minus b. Okay, because the base of the ln is Euler, with this Euler they will cancel out, so I will be left with the argument, so I go back. Now this b that is in exponent I can send at the back. Now I have Euler to the power p ln of something d of that thing. This reminds me the integral of Euler to the power ax dx. My argument is the same of the exponent. It's 1 over a, the constant Euler to the power ax. So it's the same here. So that means our answer will be equal if we apply this, the same approach here. My dx, that's all of this is my argument. It's like my x. And all of this is like my x as well. And I have a is p. So applying this approach here, that means our answer will be 1 over p times a minus b, Euler of p ln of x minus a over x minus b plus c. And a minus b will exist, will never be 0. Why? Because they say a is not the same as b, so a is different than b. So this is how we should solve this problem. Okay, so if you enjoy, leave your like, your comment, subscribe, and most importantly, share with your friends.